Let's close out this module with a demo which shows how pattern matching can be used to perform safe downcasts. Let's say that you have an object which inherits from type any. Now this could be a string or a list or just about anything. You can use pattern matching to do something different depending on what particular class your object derives from. You can use pattern matching to customize your behavior. Let's say that we have a value called radius and we have explicitly specified the type of this value to be any. In this way, we have turned off or overridden Scala's local type inference. Now we go ahead and match our variable radius, and the case clauses in this instance all test for the type of the radius variable. You can see that this is a different type of pattern. Each of the case clauses has the name of our matched variable radius followed by a colon followed by the type that we are seeking to match. In this case, radius had been assigned the value of 10, which of course is an int, and for that reason the first case clause will be matched, and that causes the return of the entire match statement to be the string integer. This is a pretty classic example of downcasting, and it really shows the flexibility of pattern matching. However, this particular type of downcasting using pattern matching is a little finicky because the scrutiny, the variable that you are seeking to match, must belong to a base class. Let's say, for instance, that we tried to specify a derived specific type such as string rather than a base class type such as any. If we now try to match radius based on its type, well, an error would be thrown. The Scala interpreter is informing us that our scrutiny, which is the variable radius, is incompatible with the pattern type because radius is a string, but we've attempted to match its type against int and double. To my mind, this detracts ever so slightly from the power of pattern matching in downcasting. Even so, it's a pretty powerful, flexible, and elegant language construct. We've reached the end of this module, and with that we've also arrived at the end of the first logical component of this course. Next up, we'll move into talking about functions, which is the most interesting part of the course, and I think also maybe the most interesting part of the Scala language. Support for functions in Scala is extremely rich, and in the upcoming module we'll talk about really interesting features such as closures, currying, partially applied functions, and so on, none of which really exist in Java or other traditional object-oriented languages. Before we get to that, let's talk about what we've just covered. In this module, we started with a run-through of some important fundamentals of Scala, concepts such as type inference, for example. We then moved on to talking about expressions in different forms. We used if-else expressions to initialize values and variables. We saw how for loops can be used both as statements and also interestingly as expressions. We understood why while loops are best avoided, and we also studied several different pattern matching constructs. With all of this under our belt, we are now ready at last to take on the fun stuff, first class functions in Scala.